Hey there, and welcome to Pomodoro Joe for Monday, the 9th of October, 2023. Today we're doing LeetCode problem 34. Find first and last position of element in sorted array. This is a medium problem. Given an array of integers, nums, sorted in non-decreasing order, so they're sorted in ascending order, find the starting and ending position of a given target value. All right? If target is not found in the array, return -1, -1. You must write an algorithm with O log n runtime complexity. All right, and then we have some examples. So we're given an array. It's already sorted in increasing order, and we're given a target. We need to find where does this target start and where does it end? What's the index where it starts and the index where it ends? So it looks like we go 0, 1, 2, 3. We find our target, so that's our start. 4, and then 5. So 4 is the end. Yep. Okay, same thing here. We've got 5 through 10. Our target is 6. 6 is not in our array, so we return -1, -1. In example 3, we have an empty array. Our target is 0, but we return -1, -1. Okay. So the simplest thing to do here would be to go from the start to the end and just look for the start of our target. Where does it start? And then look for where it stops. And you're done. But that would be an O of n runtime because you're going through all n of the elements. They're telling us we need an O log of n runtime, which means that we have to divide our search space in half for every step along the way. So we take the entire array to begin with, that's our search space. Now we have to split it into two halves, a low half and a high half. Then we can eliminate one of the halves and we recurse on the rest, or we continue on the rest. We don't have to necessarily do this recursively. All right. I don't have a ton of time, so we're going to do this quickly. Put 25 minutes on the Pomodoro timer, and we will get started. So, usually I start with my result, but I think I'll break this down into something a little bit easier. We'll have two variables. We'll have a start and an end. So I'll call start index, and I'll set it to -1 to start with, and we'll have an end index. Set that to -1. Then we're going to return our result, which will just be the start and end index here. Start index, so it's an array or a list where the start index is the first element and the end index is the second element. So this is our basic framework. Now let's actually get the start and end index here. So let's create functions for this. Let's see, we'll call this search range start and search range end. So I'm just going to create some helper functions here. Cool. Now, assuming these functions work, then our solution works. We'll find the start, we'll find the end, and we return our value. Pretty straightforward. Now we have to actually create these functions. So let's start with the first one, search range start. Now, we already know that we have to do this in an O log of n runtime, which means we have to do a binary search. Now, if you've followed my videos before, you know how to do a binary search. We'll go through it pretty quickly. So we'll have some low, and that's going to equal to 0. Actually, I'm just going to call it LO. So we have a low index, low, and we have a high index. And that's going to be the highest index we can possibly have. So that's going to be the length of our nums -1. All right, now while the low index is less than the high index, so we're going to go through. We have our entire search space that's from the low index to the high index inclusive. We're going to find the midpoint. What's the middle of this search space? We'll find the number at that midpoint. If the number at that midpoint is greater than the target number, then we can eliminate the entire upper half of our search area. Then we recurse, or we don't recurse, but we continue our loop. We'll adjust our bounds, and then we'll keep going until our bounds converge. All right, so let's find the midpoint. So the midpoint, that's going to be low, plus the difference between high and low divided by 2. So the difference between high and low tells us how many elements are in our search space. Divide that by 2 to just get half the elements. And then we have to add low to get our right index, the correct index. All right, so now if the nums at this midpoint, all right, so let's do less than first. So if the num at this midpoint is less than our target, that means we haven't found our target yet, so we can adjust our low index. We can move our entire, or eliminate our entire lower half or lower end of our range and we'll just move to the upper end and keep going. So our low index gets increased to mid plus 1. Otherwise, we have found something that's too high for our target, or it could be equal to our target, I guess. So at this point, we need to move our high index down to the midpoint. Cool. And now, if our index is the value that we're looking for, we can return this index. If it's not the value we're looking for, that means we don't actually have this value in our array, and we can return -1. So for this, we will return, let's see. This should be outside the while loop. So when we get to the end, we'll return low if the nums at low is equal to our target. Otherwise, we return -1. Our target does not exist in this array. Okay, so that's going to give us our start. Now let's find the end. Maybe I'll do this here. We'll do the search range end if start index doesn't equal -1, else the end will also be -1. Cool, that's a little bit more efficient. All right, so we've got our start, and now we have to find our end. So our end will be very similar. It's going to be a little bit different, but it's going to be very similar. So we'll still have a low, it's going to start at 0. We're still going to have a high, it's going to be at length of nums -1. And then while low. Now in this case, we actually have to do low is less than or equal to high. Because we're looking for the high index or the end index here, our low value could actually be equal to our target, but we still want to move our low value higher, or our low index higher. So it's going to be a little bit different. All right, let's see, we still need to find our midpoint. That's going to be low plus our high minus low minus 1, or divided by 2. I am totally rushing here. All right, now if our nums at this low very similar to our previous example here, but at this point I actually want to go, I think, the other way around. So I'm going to shift this around just a little bit, because our nums at low could actually equal our target, and we still want to move our low. So I'll say if the nums at low is greater than, or sorry, nums at mid, not nums at low, nums at mid, if this is greater than our target, that means our target must be somewhere below this midpoint, so I can move my high down to mid -1. Otherwise, very similar, we'll just move our low to mid +1. Cool. And then we do have to check here. So let's see, we'll return a high if high, let's see, it's possible that this will have gone down by 1. So it's possible that we might end up somewhere below 0. Is that true? Yes, I think that's true. It's possible for high to get down to low, which starts at 0, and then we do a high -1. So we still have to make sure that this is in our bounds. So it has to be greater than or equal to 0. And nums at this target, oh, I just saw a typo up here. Nums at high is equal to our target. Then we can return our high, otherwise we return -1. Okay, so I think this should do it. We're going to start off by having our start index and our end index. Our search range start function will return the start. Our search range end function will return the end, but we only need to call it if we already found a start index, so if it's not equal to -1. And then we return our result at the end. So with our start, we're going to have a low and a high. We're going to find the midpoint, and we're going to check the midpoint. If that happens to be less than our target, we'll move our low index up. If it's not, then we move our high index down. Finally, we'll just return that low index if it happens to equal the target, if the number at that low index equals the target. Otherwise, we didn't find the number, we return -1. All right, in our search end, very similar. We have a high and a low. We're going to be finding the midpoint every time, but this time we're going to check if that midpoint is greater than our target. If so, we have to move our high index down. Otherwise, we can move our low index up. Right? Again, at the very end, let's just make sure we're in bound and that we have the target. All right, let's run this, see how we do. This needs to be an equal sign. All right, so we do go out of range here. Didn't think that would be possible, but since it is possible, then let's make a check here. Low has to be less than length of nums, and nums at low is equal to target. All right, that seems to work. Let's submit to see how we do. All right, and we pass. And let's see, we do okay. We're at an 88% for runtime. Actually, we do more than okay. Wow, we're at 88% for runtime and a 14% for memory, so that's really good, actually. Now, we could jump back and do a couple really quick things to optimize this. One thing we could do is we're already calculating this length of our numbers in more than one place. So we could pull this out and make one global here, like have nums count, or actually, let's just do max index here. It's going to be this, -1. And we can replace these with max index. All right, and then this one here will be less than or equal to max index. Now, hopefully that's as efficient, but it might not be because less than is probably faster than a less than or equal to. All right, and I think I had to... Okay, let's see if that helps us at all. All right, doesn't really help us. Actually, it hurts us quite a bit. We're down to 51% for runtime, 50% for memory. So, all right, this is just one quick way to do it. By breaking it up into subproblems, it actually makes the problem a lot easier to solve. Once you solve one subproblem, then you can focus on the next. All right, that is all I have time for. I hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.